So in this video, we'll be seeing the analysis of eccentric load. So this is the most important part from this chapter or from this unit, that is direct and bending stresses. So pay attention to each and every concept. So to understand the analysis of eccentric load, first we have to understand one basic concept from engineering mechanics, that is called as a couple. Okay, so what is this couple? So this couple has few important points that we have to remember. That is, there are two equal forces. Okay, so how many forces are there? Two forces are there, and the both forces are equal. Then the second property is they are opposite in direction. Opposite in direction. So if one is positive, another one is negative, and there is a fixed distance between these two forces. Now let's quickly draw the couple, so how it really looks. So as we have seen that there are two forces which are acting. What is the magnitude of both the forces? Both the forces are of equal magnitude, same magnitude F. If on the right hand side it is 10 Newton, then this is also 10 Newton. First point is two equal forces. Second point is opposite in direction. You can see the upper force is in positive x direction and the lower force is in negative x direction. The third point is there is a fixed distance between these two forces. So there is some distance between these two forces. Okay, and this distance is a fixed distance. Now there is one property of this couple, that is this couple generates a couple equivalent moment. So this is the most important part from here. That means this arrangement which you are seeing, this generates a moment here, and that moment is called as couple equivalent moment. Now how to find out the value of that moment and the direction of movement? So the value of that moment is m is equal to force multiplied by perpendicular distance between these two forces. So this is the value of the couple equivalent moment. How to find the direction? So to find the direction, you just have to look at this force system. So look at these two forces. Okay, now take the moment about any of the two forces. If you are giving this point as A, this point as B, if you take the moment about point B, so how the rotation will be there? So this will try to rotate in this way. The direction is clockwise direction. I hope it is clear. If you want a thumb rule to identify the direction, you simply put your finger on one of the forces and then try to see how the other force is rotating about that point. If you take the example here, you try to put your finger on this point B. So now this force is sealed now. Now how this force is rotating about this point B? It is rotating like this. Okay, it will keep on rotating in clockwise direction. We'll take one more example so that it will be clear. Okay, let's take this example. So this is another couple here which is acting, and the distance between these two is E. Now what is the value of couple equivalent moment? Force into perpendicular distance. So this is the moment. How to find direction, clockwise or anti-clockwise? So you put your finger on one of the forces. So let's say we are putting our finger here. So this will rotate like this. So direction is clockwise. Now this will try to use in the main analysis of eccentric load. So this is our vertical member. On this vertical member, first we will apply an eccentric load P. Now we all know what is an eccentric load. So it is a load which is not acting on the centroidal axis. So the distance between these two, that is centroidal axis, this axis is called as centroidal axis, and the point load, this is called as eccentricity E. Now pay attention. So this was our original point load P. Now what I am doing to make it simplifier, I am applying two equal and opposite forces at this point. So pay attention. So this is one force which I am applying here, and I am applying another force at the same point from the upside. Now what is happening? This P, the green P, and the bottom red P, these are cancelling the net. Okay, so these two forces are cancelling each other. So that means the original case is still active here, and this distance is E. This distance is E. Now if you just zoom it and draw it separately, so you can see that there is one force which is P, another force here which is P, and what is the distance between two forces? This, it is E. Now this is a couple. Okay, so what is the couple equivalent moment here? The direction, the value of the moment is P into E, and the direction is, you put our finger here and try to rotate this, so it will rotate like this, and this is a clockwise direction. So we will be applying this now here. Instead of this red piece, okay, these two red piece, we will remove these two reds and we will apply only the green force which is present here. So this is the P, and what will happen to that couple? We can write that couple as a moment, that is couple equivalent moment. This is, now you can see here the main arrangement of eccentric load is converted into direct load plus moment. So we can write it here that eccentric load, it is converted into direct load plus moment. Now if the direct load is present, if the direct load is present, which type of stress will be developed? We have seen direct stress, sigma naught, and if a moment is present, then which type of stress will be developed? Bending stress, that is sigma b. So due to eccentric load, two types of stresses are developed, direct stress and bending stress. So in the next class we will be seeing now what will be the total stress which is produced, total stress. Okay,